Welcome to another video from explainingcomputers.com. This time I'm going to kick off an occasional series in which I'm going to investigate the use of a Raspberry Pi in home automation, or indeed any other kind of automation you might want to try. Now, specifically in this video, we're going to be looking at the contents of this box, which contains a hat, a piece of hardware to go on top of the Pi, which gives us three mains relays. So we can control mains devices, turn them on and off using a Raspberry Pi. Now, given that we're going to be using mains electricity in this video, I do want to sound a note of caution. Mains electricity can clearly be very dangerous, so if you don't have previous experience wiring up main circuits and using mains electricity, please don't try the things I'm going to do in this video. Anyway, with that caution out of the way, do please take care. Let's go and open up this rather exciting little box. So, here we have our exciting little cardboard box containing our new Raspberry Pi peripheral, which technically is an Electronics-Salon Raspberry Pi Power Relay Board expansion module. And this cost me £24 from Amazon in the UK, and it costs about $17 from Amazon in the United States, and about €22 for a very similar looking product on the German Amazon website. And of course all the links will be in the video description. So we get inside, I'll bring in a Stanley the knife and just cut through the thing on the back there. This should be a very straightforward unboxing, even for me. Oh, it is, look, there it is inside. And oh, it's an anti-static bag. Good to see those, not always getting those these days. We'll just bring in Mr. Scissors to get inside here. And there we are, crinkle, crinkle, crinkle. Hope it'll come out, come out, come out. And there we are, there is our relay board. And if we take a bit of a closer look at it, you can see that this is a hat, with hat standing for hardware attached on top. And hat is basically a standard for peripheral boards for the Raspberry Pi that was introduced by the Raspberry Pi Foundation back in 2014. And if we turn this thing over, you'll see it will attach to the Raspberry Pi using the GPIO connector, and it's got some risers which will separate it from the board and allow it to be attached to the board. And this would fit on top of most Raspberry Pis that have been made. Specifically, this will fit on the original Raspberry Pi B+, and a Raspberry Pi 2B, a Raspberry Pi 3B, a Raspberry Pi 3B+, and indeed the Raspberry Pi 3A+ as well. So this will go on lots of different Raspberry Pis. So what does it do? Well, basically we've got three relays here, and each of these relays is interfaced to a GPIO pin on the Raspberry Pi via a Darlington transistor, which allows the Pi to switch these relays. And the relays will actually control quite high power devices. Specifically, they can switch up to 10 amps at up to 240 volts AC, or up to 5 amps at a 30 volts DC. And one of the nice things about this board is although each relay is hardwired initially to a particular GPIO pin, it doesn't have to be. Because if we look down here, you can see we've got some jumpers, and these make the hardwired connections between the relays 1, 2 and 3 to the GPIO pins at 21, 20 and 26, but we could take these jumpers off and put wires across from these pins to the particular GPIO outputs we wanted to use to trigger the relays. So that's basically what this thing does, how it works. Let's now put it onto a Raspberry Pi. Here's a Raspberry Pi 3 Model B+, just waiting to have the board put onto it. And I've noticed that we can't put it straight on because the screws here are already in, so I've got to get those out first. And there we are, those are out. So this would now fit onto the Raspberry Pi. It will go on something like this, I think, if I can just get it on correctly, like that. It'll push down into place. There we are, that's onto the Raspberry Pi, and it needs to be connected on, and you could put the screws back in here obviously to hold it in place, but I'm not actually going to do that. I'm going to use these, which are some more risers I've purchased, and I'm going to put the risers under here because I want to be able to have this connected to a baseboard, because I want to connect it down because we are going to be switching mains components. So I'll just do that. And there we are, the board is all ready. It's got everything, all this hardware under there, but that is now ready to use to control our mains devices. So there we are, it is all set up. I think I'll now go and think about some appropriate Python code. So here I am back again. We've got the Pi all up and running, and if you think this shot looks a little bit dark, a little bit grainy, the reason is I've got the lighting set so we can see illuminated LEDs. And this LED on the board just means the hat is on, but there's also 3 LEDs in front of the relays which we can use for test purposes. So if we go across to a Raspbian, and yes, I've got a rather large clock on my desktop, we'll be using that later in one of our tests, but for now I'm going to go to a programming and to a Python 3 to the interactive development environment. And there we are, that's come up there. And if I just bring in a piece of test code I've written to test out the unit over there, that'll come in. And what have we got going on here? Well, basically we're bringing in 2 libraries, GPIO and time, that's happening there. And then we're setting the numbering mode for the GPIO connector and defining some output pins. And it's worth noting that there are 2 ways you can define the numbers for the GPIO pins on the Raspberry Pi for referring to them. Board numbering, where you just basically label the pins 1, 2, 3, 4, 5, 6 across in a nice straightforward way. That's what I normally use. But there's also a mode called BCM, which is what we're using here. And BCM is the Broadcom internal system for numbering the GPIO pins. And that's what they're using by default on this board, in terms of the fact that, if we remember, on the board there were some jumpers set to use the GPIO pins 20, 26 and 21 to control the relays. And that's under BCM numbering. So we could use board numbering and move these numbers around, but for now we'll stick with BCM. And I've set up here the output pins therefore to be 20, 26 and 21. I've then got a little cycle here just to turn the relays on and off in sequence. I've got this inside a try finally configuration, so that when we crash out of this using Control-C, there's no other way out of this. It'll always clean up the GPIO stuff at the end by executing the finally stuff there. But inside try, we've then got a while loop. It says while true, so this will always be true. This loop will go on forever. It's basically going to turn on the output 21, turn on that relay. Time sleep 1 means basically wait for 1 second, then we'll turn it off, turn on the next one, wait for a second again, and that'll keep going. So if we just run this code, well, I'll do, there we are, could press F5, and we'll go back to the board, and yes, that is working very nicely. Hopefully you can see the relays not just coming on, being reflected in the back of the relay as well. That works quite nicely, doesn't it? Hopefully you can hear it as well. I like that, it's a really good noise, isn't it? If I just press Control-C to stop this, it will stop. And if I just come out of that, just to show you can use the board numbering, I've got that written up in code as well. You probably noticed that earlier. This is the board numbering. Exactly the same piece of code, except here we're using board numbering, which means we're using GPIO pins 37, 38 and 40. But if I run this again, I'll press F5 this time, cut back to the board, and again, hopefully our relays will cycle. Yes, that's working absolutely fine. So we proved the board works. Let's now think about connecting it to some mains devices. So what I'm going to do now is to get our Raspberry Pi with its mains relay hat controlling 3 mains light bulbs. And here's our bulbs here. And I've also got 3 bulb holders. That'll go in there. That's a bayonet holder, as we use most of the time in the UK. And I've also got a terminal strip and a bit of a plastic card to mount the Pi on, and a piece of wood as well, and various screws and things. So this is the moment that explaining computers goes all A-Team and MacGyver, because I'm going to be doing lots of drilling and lots of screwing down and lots and lots and lots of wiring up. Lots and lots of wiring up. And the final result will look like this. Here we are. Every home should have one, shouldn't it? This is our test board for running our 3 bulbs from the Raspberry Pi via this relay hat. And basically we've got power coming in here. This wire used to be on an old iron, you know. It's a very short wire now because most of the wire's been used to do all the wiring here. But basically what is going on, we've got Brown is live in the UK in the main, so basically live comes in there. We've got 3 terminals with live. They go into the input onto 3 relays over here on the relay board, and the 3 outputs go to the 3 bayonet bulb holders, and then blue is neutral, which goes out to 3 connectors for neutral, which goes back out to the wire and back out to the plug and the mains again. And if you want to see that a bit more clearly, you can see it on this circuit diagram that shows you how everything is wired up. So there we are, all raring to go. We just need to add the bulbs, so I'll do that now. That should be nice and straightforward. Just put these into the holders like that. And so if I just get this all connected up and running, we can go back into Raspbian and rerun our code from previously. And hopefully, yes! Sorry, I was just a bit surprised there. It's working. It's difficult to get the lighting right on this because clearly these are quite bright bulbs. That's why I've chosen a black background for once, but it works. It works really well. I love the noise. I love the bulbs going on and off. It's always great to use a Raspberry Pi to control LEDs to turn them on and off, but there's something a lot more visceral about using a Raspberry Pi to control mains bulbs, mains appliances. I think that's really cool. I'm very pleased with the result of wiring up this test board. Now, I'm sure some of you are asking yourselves, what is the point of this thing? What are you going to do with this setup? And I could say, well, if you're going to one of those light bulb sequencing parties, this could be very handy. But other than that, you might, for example, want to use the Raspberry Pi with a relay controller like this to turn light on and off when you're away from home to make it look like your house is occupied. You could turn on radios and things like that, all types of things with these relays. And to do that, what I've done is taken our code from previously and altered it slightly. So here we're importing two libraries again, GPIO, but this time date time rather than time. And again, I've got the numbering set up for here. I've gone back to board numbering. I just happen to like it. I've set up the pins. We've still got our try finally thing going on. And inside our infinite loop here, it's basically saying now equals datetime dot datetime now dot time, which basically means we can say if now hour equals say 20, that's 8 o'clock, isn't it? And minute is 44. It'll then turn on that particular output, turn on one of the bulbs. And then if it's say 2045, it'll turn another one on. And if it's 2046, it'll turn them both off. You could turn all sorts of things up in here, so you can turn things on and off. And it's worth pointing out the Pi doesn't have a real-time clock, but it will pick up the time from Wi-Fi. You could, of course, always set the time yourself when you started this thing off. And I point out if you ran this over a long period of time, over many days or even weeks, it would happen at the same time each day. You could have all sorts of things inside here. So if we run this code, let's press F5 to run the thing up. There it is, and we'll make sure our clock stays on screen there. And we'll flick back to the bulbs, and I'll put a bit of fast motion in because clearly we don't want to watch it forever. But actually, it's coming up to 8:44, isn't it? The first of our ones, which is something that's going to happen on. So let's see what happens. It's exciting as the clock gets to the top. Is it going to work? 8:44. Yes, a bulb has come on. So we'll now flick forward in time through the magic of fast forwarding. And here we are coming up to the next minute, and hopefully, yes, another bulb has gone on, and we'll flick forward in time again. And here we are back in real time, and oh, there we are, the bulbs have gone out. So clearly it works. We proved we can do something useful with the relay board connected to the Raspberry Pi. And I would point out there's all kinds of ways of triggering GPIO pins. You could use switches, you could use light sensors, motion sensors, things like that. And we'll be looking at some of the options later in this series. In this video, we've seen how it's possible to control mains devices wired directly to a Raspberry Pi. But what if you want to control mains devices which are spread all around your home, a long distance from the Pi, and you don't want to have lots of mains wires sort of spread all over the place, or maybe you just don't want to do all the mains wiring yourself? Well, is there an answer to that? And the answer, of course, is yes. You can use wireless. And so in the next video in this series, we'll be looking at devices like this, wireless adapters. You plug this into a socket, you plug your device into this device itself, and you can control it wirelessly from a Raspberry Pi. But now that's it for this video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.